Okay, we're in section 19 of the notes. We're doing the examples now. And again, it's hopeful that you've paid attention to what we presented to you in the lecture portion. And this is the section on rational exponents. What's critical here is though, excuse me, is that you understand integer exponents because these are going to be conceptually more difficult to understand. And by that, understanding integer exponents, the rules should start making more sense to you. Not like a memorization skill, but more sense to you. And they're basic rules. We list them all here for you. Now, in the past, I just boxed 3 of those rules. I boxed 7, 8, and 9 in the past, because with integer exponents, these sometimes are a little bit confusing. But now what we got to do is we really have to pay attention to these rules over here, 1 through 6. All right. So what we're going to do now is we're going to talk about the examples as they relate to what was presented in the lecture. All right, let me move over to the whiteboard. And as I do that, I'm going to do another share with you. Give me a second. Excuse me. Okay, so we're at the whiteboard now, and what I'm going to do is just talk about example number 1. And so example number 1 says simplify it. And someone says, I wonder what that means. Some people misunderstand this, particularly if they don't understand what an exponent is. An exponent is saying they want one of the 2 equal parts of that number 16. Well, let me write that down for you. So 16 to the 1/2 means they want one of the 2 equal parts of 16. Now, when we say parts, we're talking about the factors of 16. Does 16 have 2 equal factors? It does. 4 times 4. So one of those 2 equal factors would be the number 4. The other meaning of this, 16 to the 1/2, is just the square root of 16, which again is 4. Look at the key and you'll see it. All right, number 2 is on the next page. Let me go to that. And then I'm going to simplify h to the 2/3. All right, let me write this down for you. And h to the 2/3, what does it mean? It means they want 2 of the 3 equal factors of 8. So someone says, what are the equal factors of 8? And are there 3 of them? There are. 2 times 2 times 2. That's 8. What do they want? They want 2 of them. What would 2 of them give you? 4. Right? There's a variety of ways to write this down with a radical notation. And let me go through that with you. For one thing, I could write down it's the cube root of 8 squared, or I could write down it's the cube root of 8 quantity squared. All right, they're both the same. For example, the first one, the cube root of 8 squared, write this over here, is the cube root of 64, and the cube root of 64 is 4. If you wrote down the cube root of 8 and then squared it, well, the cube root of 8 is 2, and if you square 2, you'd get 4. So it's always going to lead to 4. Look at the key, make sure you say that. My claim over here, though, is I really think you should pay attention to the meaning of the exponent, and that is 2 of 3 equal parts. All right, let's do 16. And what's this asking for? Well, it's asking for 3 of the 4 equal parts of 16. It wants 3 of the 4 equal parts. Now, when I say parts, I'm talking about factors. Now, this may not be possible. Maybe I don't know what those numbers are, but I think I do. And what do I mean by that? 2 times 2 times 2 times 2 is 16. And that's 4 parts. What do they want? They want 3 of those parts. What would that give me? Well, 2 times 2 times 2 is 8. You can also write this in radical notation. So 16 to the 3/4 is the 4th root of 16 cubed, or you could write down the 4th root of 16 quantity cubed. I want to point out 16 cubed is probably not where you want to go. Now, could you do it? Yeah, you could. And I'm going to try to do it in my head. And that's going to be 2 to the 12th. Ooh, that's a big number. I don't think I want to do that. But I think I can do the 4th root of 16. And what's the 4th root of 16? 2. What's 2 cubed? 8. All right. Again, if you want to do 16 cubed in the 4th root, you could. But I gotta be honest with you, this one The arithmetic is way too difficult. You should appreciate how simple it was to take the 4 through to 16 though. All right, what's the answer? The answer is 8. Let's look at the key, make sure the answer is saying that, and it is. All right, 25, I'm sorry, number 4, which is 25 to the 3 halves. I'll write that down, and it's a little bit difficult, it's an improper fraction. What do they want? They want 3 of the 2 equal factors of 25. Oops, sorry about that. All right, I have to know what the equal factors of 25 are, and there's 2 of them, 5 times 5. They want 3 of the 2 equal factors. Well, this is a little bit conceptually like difficult. I mean, how could you do that? There's only 2 there. Well, it says take 3 of them, and I'll put that down for you. And what would 3 of them be? 5, 5, and 5. So what do? We took 3 of those equal factors. What are they? 5s. 3 5s go down. What does that give me? 125. I could also use radical notation. Let me write this down for you. It would be 25 to the 3 halves. I'm going to point this out to you. 2 is the index of the radical, which can be the square root of 25 cubed. Or if you prefer, you could write down the square root of 25 cubed. They're both the same, right? I think the first one's easier because the square root of 25 is easy. 25 cubed for me is too difficult, but the square root of 25 is 5, and 5 cubed is 5 times 5 times 5, which is 125. A variety of ways of thinking about it. Check the answer, and it should be staring at you. All right, now we're getting to the problems where we're going to be using rules of exponents. All right, so I want to put the rule that we're using over here, and the rule is this: a to the n times a to the m is a to the n plus m. This is one of the rules we've given you. Again, the hope is that you practice the integer exponents and that makes sense to you. All right, so let's write this down. So I have the same base. I pointed out to you. Same base, just like over here, the same base. I'm going to raise that base now, which is x, to the sum of those 2 exponents, which is 1/2 plus 7/2. You're expected to do arithmetic if you can. 1/2 plus 7/2 is 8/2. And that simplifies. What's 8/2? It's 4. Check the answer key. All right, let's go to 6. And this one looks far more difficult. All right, a lot more going on here. Now, granted, I realize the negative exponents are still trouble, but I'm still using the same rule. Let me write that rule down for you. A to the n times a to the m is a to the n plus m. And you know what I'm saying is the base is the same. It's just a. Over here, well, there's 3 of them. You can extend this thing. It's going to be the addition of those 3 exponents now. Let me write that down for you. So it's going to be a exponent minus 7/15 plus the next exponent 4/5 plus the next exponent 2/3. Well, somewhat more of a challenge, but I have to get a common denominator. That would be 15. And you would get minus 7. What times 5 would give you 15 is 3. So 3 times 4 is 12. What times 3 gives you 15? 5. And 5 times 2 is 10. Let's keep going. I'm going to get over here, I get 15, denominator. Let's see, minus 7 plus 12 is 5, and 5 plus 10 is 15. And what do you get? Well, 15 over 15 is 1, which means there's only one factor of a. Look at the k, and make sure you can agree with it. So the next one, now this one's a little different. I want to put rule over here. We're using a to the n raised to the mth power is going to be a to the n times m, right? Important rule. And again, the hope is that you've practiced the integer exponents and you made sense out of that. So what do I do over here? Well, I'm going to write it down for you. It's going to be x 6 times minus 2/3. Well, what's that going to be? Let's go through that. 3 goes into 3 once, and it goes into 6 2 times. So what do you get? X 2 times minus 2 is minus 4. Now, my claim over here is at some point you should stop saying, oh, negative exponents are bad. They're really not. So put a box in that. However, at Essex at this level, they want you to write it down as a positive power. And that really goes back to the integer exponents we had before. What do we see? We see two answers in the K. I'll point that out to you. This one's fine for me, but this is what the school wants you to write down, 1 over x to the fourth power. Let's go to the next one. Again, what rule am I using? This rule over here, a to the n raised to the nth power is a to the n times n. Again, the hope is that when you practice the integer exponents in the past, that this stuff is making more sense to you. Let's write that down. X to the minus 4/3 times minus 3/8. I'm just going to do a straightforward multiplication over here. It's x. And what would that give you? Let's see, minus 4 times minus 3 is 12. And 3 times 8 is 24. That reduces and was reduced to x to the 1/2 power. Check the key and make sure you can agree with it. All right, let's keep going. Now this one, there's two things going on over here. And what I'm claiming over here is that, basically it's the same rule over and over again, but I got two things going on over here. Whoops, sorry about that. And let me write those two things down for you. So it's going to be x to the 5th raised to the minus 2/5. We'll do that later. Times y to the minus 10th to the minus 2/5. So I'm really back to the same rule, and that's going to be a to the n raised to the m is a n times n. Well, the first one, let's see if we can do that. And what am I doing? And I'll write this on the side for you. I'm doing 5 times minus 2/5. What would that give you? Well, the 5s cancel. You just get a minus 2. All right, let me cross this out. And again, I'm done with that. Let's do the next one, which is multiplication of exponents. What do I get? Well, I get minus 10 times minus 2/5. What do you get over there? Well, if you looked at it, it would be 20 over 5, which is 4. I'll write that down for you. Okay, I do not mind the answer. I want to point out at Essex, though, they don't want you to write negative exponents down. That's something you learn about when you do the integer exponent problems. Let's look at the K, and I'm seeing the answer. See that answer there, and I see an answer there. Let's go to number 10, and that'll be the last problem. A lot of students get confused by this, and the reason for that is they really have not spent enough time with the integer exponents. But the claim over here is what happens to a lot of students are looking at the problem, and they try to do the internal sum, which is y to the 2/3 plus y to the minus 1/3. You can't do it. They're not like terms. All right, so what you have to do is you have to use the distributive product multiplication. So this is going to be distributed across these two terms, one at a time. Let me go through that. So it's going to be equal y to the 1/3 times y to the 2/3 plus y to the 1/3 times y to the minus 1/3. And what rule am I using now? A to the n times a to the m is a to the n plus m. Do the first one. The first one's going to be y. I'm adding the two exponents together. You would get 3/3. We'll simplify that later. Plus y. I'm adding those two exponents together, and that would give you 0/3. I'm going to simplify that. 3/3 is 1, and 0/3 is 0. What does this give me? Y plus y to the 0 is going to be 1. Simplified nicely. Again, we recommend you look at the K. Now, some people are going to say, well, I could do that really quickly without writing things down. Yeah, you can. And we don't need you to write things down in something that simple. However, we do want you to know what the process is. Okay, next up is someone going to say, when do I get a chance to try? Well, we're not stopping you from trying. We really want you to try. So what you have to do now on your own is you got to start doing this homework business. And what does that mean? You do every single problem you do, right? These problems here have a problem and they also have solutions down for you, problem and a solution down for you. Do them all. Again, if you need additional support, you need to come by during office hours and I'll be more than happy to help you, including there's also tutors at Essex County College that will also be more than happy to help you through this material. Your goal is to learn the material. The only way you can do that, attend the lectures, watch me do examples, and then you need a chance to try it on your own. After you go through all that process, watching examples, watching me do the lecture, doing examples on your own, do the WebAssign. WebAssign after doing all that work should seem rather simple to you. All right. Thanks for paying attention. See you next time.